Hi student, welcome to my channel Education Shop. In this video we solve problem 11.56 from the book Heat and Mass Transfer by Single 5th edition. Here is the statement of the problem. Engine oil CP value is 2100 joule per kg Kelvin is to be heated from 20 centigrade to 60 centigrade at a rate of 0.3 kg per second in a 2 centimeter diameter thin walled copper tube by condensing steam outside at a temperatures of 130 centigrade. The enthalpy of vaporization is 2174 kilojoule per kg for an overall heat transfer coefficient of 650 watt per meter square dot Kelvin. Determine the rate of heat transfer and the length of the tube required to achieve it. This schematic diagram, you can see the oil is moving inside the tube at a temperature of 20 centigrade and the mass flow rate of the cooled oil is 0.3 kg per second. Its temperature rises to 60 centigrade after it's absorbed heat from the steam, that is 60 centigrade. The inside temperatures of the steam is 130 centigrade and the condensate out we obtain is also at the same temperature, that is 130 centigrade. Let me write the data that is given in the statement. First of all, the CP value, that is 2100 joule per kg Kelvin. We are interested to convert this value into kilojoule, that's why we'll divide with 1000. Dividing with 1000, it will be equal to 2.1 kilojoule per kg Kelvin. The inside temperatures of the cooled fluid TCN, that is 20 centigrade. The outside temperature of the cooled outlet of the cool fluid is 0.3 kg per second. The internal diameter of the tube is 2 centimeter, means to say di is equal to 2 multiplied 10 to the power minus 2 meter. The hot temperature in is equal to the hot temperature out, and that temperature is 130 centigrade, and the enthalpy of vaporizations of steam at this 130 centigrade is HFG, and its value is 2174 kilojoule per kg. The overall heat transfer coefficient is also given, that is 650 watt per meter square dot Kelvin. We need to calculate the heat transfer rate in the heat exchanger, the length of the tube. Now let's come toward its solution. We are interested to find the rate of heat transfer in this heat exchanger, that is equal to U surface area and the log mean temperature difference. The U value is given in the statement. First we will find the log mean temperature difference. Here two things are unknown, the surface area of the tube and the amount of heat transfer rate in the heat exchanger. So that's why we cannot use this equation directly. We will first find Q dot LMTD value and then we put in this equation, and we can find the surface area of the tube. First we will find the LMTD value. You know that delta T1 is equal to T hot in minus T cooled out. T hot in is 130 and T cooled out 60. After subtraction it is then delta T2 is equal to T hot out minus T cooled in. T hot out is 130 and T cooled in is 20. After subtraction it is 110 centigrade. And we also know that log mean temperature difference is equal to delta T1 minus delta T2 divided by ln delta T1 divided by delta T2. Simply put the value and you will get the log mean temperature difference. Delta T1 is 70 minus delta T2 110 divided by ln 70 divided by 110. Let me solve this on calculator. Press this equal button and you will get the LMTD value, that is almost 88.5 centigrade. We also know that the amount of heat absorbed by the cooled fluid is equal to m dot the cooled fluid CP value of the cooled fluid and temperature change in the cooled fluid, that is T cooled out minus T cooled in. What is m dot C? That is given 0.3. CP value is 2.1 kilojoule per kg Kelvin, and then T cooled out, that is 60, and is T cooled in, that is 30. Just simply multiply this and you will get the amount of heat absorbed by the cooled fluid, that is actually equal to the rate of heat transfer in the heat exchanger, that is 25.2 kilowatt. Now LMTD value has been calculated. Q dot value is calculated. Here you can see, put this U LMTD and Q dot value in this equation, you can easily find the surface area, and this is our first answer that is asked in the statement. Here you can see, and we can say that surface area is equal to, from this equation, equal to Q dot U LMTD. Q dot is 25.2, but this is in kilo. Multiply 1000 with it to convert into watt. The U value is 650. LMTD value is 88.5. Solve this on calculator and it will give you the surface area, that is 0.438 meters square. But we are interested to find the length of the heat exchanger. That's why surface area of the tube is equal to pi d. L length is equal to surface area divided by pi d. Surface area is 0.438. Pi value of d is 2 multiplied 10 to the power minus 2. Just simply solve this on calculator and it will give you the length of the heat exchanger, that is almost 7 meters. And this is our final answer that is asked in the statement. I hope you understand. If still there any confusion, you can ask in the comments. Please subscribe to the channel if you haven't.